Well, hello everyone. Today we're going to look at the first section in chapter 3, and we're going to deal with essentially linear functions and being able to sketch them and use them in various ways. So here we go. So here is a list of the 6 subcategories within this section. So we'll start with the first one, which is Cartesian coordinate system and the 4 quadrants. So what the Cartesian coordinate system allows us to do is it allows us to tell us the location of any point in 2-dimensional space. And we do that by giving an ordered pair. So for instance, I could say that A has the coordinates 2, 3. And what that would look like would be you'd go 2 in the positive x direction, followed by 3 in the y direction, and that would be the location of A. Now, if I had another point B, and let's say its coordinates are -1, 1, we would go -1 in the x direction, followed by 1 in the positive y direction, and that's where B would go. Let's do 2 more. Well, suppose I do C and it's -3, -4. Well, you would go 3 to the left, that's -3, and 4 down, 1, 2, 3, 4 to here. And that would get us to here, and this is C. And lastly, we have a point D, and let's suppose its coordinates were 4, 2. Well, you'd go 4 in the x, and let's change that to 4, -2. So 4 in the x and 2 down, and that puts us here, and that would be D. So we have A, B, C, and D. And any point in 2D space can be described by these ordered pairs. For instance, there's one really special point in the center called the origin, and it has coordinates 0, 0. Well, where are we going now? Well, the next thing we want to talk about are what are called the 4 quadrants. What they're doing here is they're basically splitting this entire infinite 2-dimensional space into 4 distinct groups. Anything in this region here, don't need to shade it typically, but anything in this region is quadrant 1. Anything over here is considered to be points in quadrant 2. Anything down here is quadrant 3, and anything over here is quadrant 4. So you might get a question like in your homework, 1, -3, and you'd like to know which quadrant it's in. Well, 1, -3 would be what here, and that's clearly in the 4th quadrant. And if I gave you the point -2, 2, well, that would be -2, 2 would be about here, and that's clearly in the 2nd quadrant. Now, if you look carefully, you can actually tell which quadrant a point is in without actually plotting it, and that's useful, especially if the coordinates are really unusual numbers, like 510, -99, right? You don't really want to plot points like that. So here's a little pattern for you. If the x and the y coordinate are both positive, then you will be in quadrant 1. So 5, 3, 99, a million. That would get you into quadrant 1. Now, suppose you were a -x coordinate, but a positive y coordinate. Things like -1, 2, -7, 99. Then in that situation, you will be in quadrant 2. The next one we're going to do is both of the coordinates are negative. And that would put you down here. Things like -3, -7, or whatever. And in those situations, you would be in quadrant 3. And the last one would be if you have a combination where the x is positive and the y is negative. And that will only happen for points that are in the fourth quadrant. And that's essentially all you need to know at this point. Can you plot a point in 2D space? Can you tell me which quadrant the point is in? And these are really starter skills that we're going to build on. So let's move a little bit further to our second topic. And you're going to be asked to find the length of a line segment or find the distance between 2 points. I prefer describing it as a distance between 2 points. They are the same thing. Suppose I have the point P and its coordinates are 1, 2. And I have another point, so that would put it here. And I have a second point Q, and its coordinates are 2, 3, 4, 5, 4. That would put it way up here, right? 5, 4. Then I would like to know the distance between P and Q. Right? I would like to know the length of that, right? Another way of saying it. And so we can do that by using a formula. It's called the distance formula. And it depends on which textbook you look up, how this distance formula is written. They are all exactly equivalent. They might look a little bit different, but they're essentially the same thing. And so what you're going to do is that we're going to call this guy here x1, y1. We're going to call these two numbers here x2, y2. And the distance formula says if you want to find the distance between P to Q, right, let's call it D for short, you get it by this formula. It's the x coordinate x2 take away x1 squared. It's the difference in the x coordinates squared plus the difference in the y coordinates squared. So in this situation here, it would be the square root of 5 take away 1 squared plus 4 take away 2 squared. And in this case, I get 4 squared, add 2 squared. And that becomes 16 plus 4. And so the answer is the square root of 20. You do not need to turn that into a decimal and round it off to, I think it's 4.45 or whatever. You only need to leave it as a square root of 20. Or, as you can find later on, you can actually simplify that down to 2 root 5. But right now, square root of 20 is fine. And that's called the distance formula. And so if you give me any 2 points, I can tell you the distance between them, and I don't need to actually draw the thing anyway. So let's suppose I tell you P1, just to be different, is 5, -2, and the other point is called P2, because evidently this book likes using funny names. I'm going to call the first one x1, y1. I'm going to call this guy x2, y2. And we're being asked to find the distance between them. So we will do x2 take away x1, the difference in the x's squared, plus y2 take away y1 squared. So it's going to be the square root of -3 take away 5. So -3 subtract 5, and you square it. And it's going to be 4 subtract this guy. So you're actually going to be subtracting a negative number. So let's see what that looks like. Negative 3 take away 5 is negative 8, and you'll square that. 4 take away negative 2 is 4 add 2, so that gets you 6, and you square it. And 8 squared is 64, because negative 8 times negative 8 is positive 64, and 6 squared is 36. And we now get the square root of 100. Now, it's okay to leave the answer as the square root of 20 because there's not really much you can do to it. But sometimes, and this is one of those sometimes, you do get an answer that has a perfect square root. So the square root of 100 is 10, and that's what you would use. So that is how you find the distance between 2 points. You use what's called the distance formula, and there's 2 examples for you. Now, the other part of this, or next part, I should say, number 3, is we're going to find the midpoint of 2 numbers, 2 coordinates. So imagine that you had a point here, P, and you had another point up here, I'll call it Q. Then the midpoint is a point halfway between P and Q. Let's call it M. And so we need to find the coordinates of the midpoint. And there's a formula for that. So the coordinates of the midpoint of P and Q. Let's take P and call it x1, y1. And let's do Q and call that guy x2, y2. Then the coordinates of the midpoint, let's call that guy M. You get it by adding the 2x coordinates together and halving them, essentially getting their average, and adding the 2 y coordinates together and halving it, right, getting their average. So an example might be that P is the point 5, 2, and that Q is the point 11, 20. Now, I don't really want to plot those and draw them with a ruler and guesstimate where the middle is, but let's just use the midpoint formula. Then M, the midpoint, will be, let's put the labels on them. That guy is x1, y1. That guy is x2, y2. Then according to our formula, you add the x coordinates together and half it, and you add the y coordinates together and you half it. So the midpoint will be 5 add 11, and you half it, and 2 add 20, and then you half it. And this guy here is what? 16 divided by 2, which is 8. And this guy is 22 divided by 2 is 11. And there is your coordinate of your midpoint. Let's suppose that we are asked to find the midpoint, and the 2 points are called P1, which is this guy, and and P2. So that guy. Then the midpoint is going to be add the x's together and half it. Add the y's together and half it. And there is your x1, y1. There is your x2, y2. So let's see what the midpoint looks like. it's -3 add -6. And then you have it. And it's 1 add 5. And then you have it. -3 add -6 is essentially -9, and then you have it. And 1 add 5 is 6, and 6 divided by 3, 6 divided by 2 gets you 3, and that's the answer. And it's okay, and we prefer you to leave the answer like 9/2 rather than 4.5 or -4.5. Leave it like that. And that's essentially how you take care of finding the coordinates of midpoints. So let's move on to number 4. Graphing linear equations using points on the graph. Right. So a linear equation takes a number of different forms. I'll show you the most common ones. You get them written as y equals 2x plus 3, a half x minus 20, things that look like that. And then the other version that you get, a 3 there, is 2x plus 3y equals 6. That's also, right? So if you need to, because you want to know this, this is called the standard form. And this is called the y equals form. So we are going to sketch what the graphs of these look like. Essentially, when you graph a function, in this case a linear equation function, what you're trying to do is write, it is on a piece of paper on a 2D XY grid, do all the points where this is true. All the points where the y coordinate is twice what the x coordinate is, add 3. Or in this case, twice the x coordinate plus 3 times the y coordinate should equal 6. And obviously there's an infinite number of possible points where that's true. And nobody can plot an infinite number. The good news is that these are always going to be straight lines. And because they're going to be straight lines, we can actually simplify the process by realizing that you don't need to find tons and tons of points. You can just get by with finding maybe 2 or 3 points and then just joining them all up. And we are going to do that by doing points on a graph, as it's called. So here is my axis. Hopefully you can imagine this being nice square paper. And let's do this one. Y equals 2x add 3. Well, all you need to do is choose some x coordinates. So I'm going to choose x as 0. I'm going to choose x as 1. And then I'm going to choose x equals 2. And for each x value, I can now calculate what the y coordinate would be. The y coordinate would be 2 lots of nothing add 3. The y coordinate would be, when x is 1, 2 lots of 1 add 3. And in this third case, when x is 2, the y coordinate would be 2 lots of 2 add 3, and you get that. So all you really need to do now is to put these together and say, one of the ordered pairs, one of the coordinates is 0, 3, another one is 1, 5, and the third one is 2, 7. And you can then go 0. I'm going to have to put a scale on this, so 2, 4, 6, 8. And I don't think I'll need a scale the other way. So you plot the point 0, 3, which would be 0 along, 3 up. You plot the point 1, 5, which would be here. And you plot the point 2, 7, which would be here. And then you draw a line through all these points. And essentially that line continues for eternity. And what we've just drawn is a graph of y equals 2x plus 3. Hopefully so far so good. Right. Now, what can make your life difficult? Well, one of the things they can do is give you an equation, the y equals form, let's deal with them first, where you have got a fraction there. So 2/3 x minus a half x, things like that, right? In fact, let's make this negative. Negative 3/4 x, bigger. Choosing the x coordinates, and it's a good idea to choose at least 3. And that way, if you make a mistake, you'll know it. Because if I made a mistake here and one of my dots was up here, you can't get a single straight line that goes here, up here, and down there, right? They don't match. So that if you do 2, you might make a mistake, but you'll never know it because 2 points will always make a straight line. So how do you choose good values of x, right? We don't want to make life horrible and try and plot 1 3/4 or 7/3, 9/8. You don't want weird numbers that are really not going to work. So when you have a fraction here, choose values of x in the 4 times table. So 4 times 0, 4 times 1, 4 times 2. Now, by choosing 0, 4, and 8, what that is going to do is it's going to make the y coordinate easier to calculate and a nicer number, a nice whole number typically. So let's see what we get. When y is 0, negative 3/4 times nothing add 2 gets you 2. When x is 4, negative 3/4 times 4 is negative 3. Negative 3 add 2 gets me negative 1. And when x is 8, you get that guy times 8 is negative 6. Negative 6 add 2 gets me negative 4. So I have the point 0, 2, the ordered pair 4, negative 1, the coordinate 8, negative 4. And then what I do, and I'm going to show you in a few moments how you can do this a lot neater rather than scratch paper and so on, you know, how the homework asks you to do it. So what kind of scale would I need? 1, 2, 3, 4, 5, 6, 7, 8. Okay, I can do that. And 1, 2, 3, 4. 1, 2, 3, 4. 2, 3, 4. Better. Right, there's my basic. 0, 2 is here. 4, negative 1 is here. And 8, negative 4 is here. And so I can join these together and then continue the line. And this is y equals negative 3/4 x add 2. Hopefully, you've got the idea of how to tackle that. Now, let's look at the other kind, the standard form. So let's suppose I get 2x plus 3y equals 12. A little bit more work here, but essentially what we're going to do is we're going to find some points. And so I'm going to choose x equals 0. I'm then going to choose x equals 3. And then I'm going to choose x equals 6. And if you're wondering why I'm not just picking 0, 1, and 2, I could try that, but I can tell you right now that the y coordinates would be pretty ugly, right? And I want to try and see if I can make nice, round, whole number y coordinates. And so when you look at these two guys and you look at this one, it looks to me like as long as I make these guys multiples of 3, I'm likely to get good answers. So let's see how that works. Right, if you take x equals 0, the equation 2x plus 3y equals 12 becomes 2 lots of 0, which is 0 plus 3y equals 12, which then is 3y should be 12, and dividing both sides by 3, you get 4, and so we have our first pair, 0, 4. Now, if I move on to my second one, x equals 3, I'm going to have 2x plus 3y equals 12. So that's going to be 2 lots of 3 add 3y should equal 12. That's 6 add 3y should be 12. Essentially, I'm solving an equation. So I'll subtract 6 from both sides and divide both sides by 3. And that gets me my second order pair, 3, 2. And for completeness sake, I'm going to do x equals 6. And that's going to be 2 lots of x plus 3 lots of the y coordinate should equal 12. 2 lots of 6 add 3y equals 12. 12 add 3y equals 12. So 3y is going to be 0. Dividing both sides by 3, you get 0. And so I have that guy as my third pair. And just to save some time, I'm going to put it on this graph over here. So I've got 0, 4, which is here. I have 3, 2, which is here. And I have 6, 0 is here. And if we join these 3 points together, I now have, oops, that's probably a little bit higher. There we go. I now have 2x plus 3y is 12. So let's kind of show you, what does that look like? You know, what do the homework questions look like? Because you can't really do this on the computer. It's really impractical. So I'm going to move over and we're going to have a look at how you would tackle the same kind of question on WebAssign homework. I'm making an assumption that I hope is true, or else I'm in real trouble. What we're going to do here is we're going to do that guy there, and we're going to do y equals 3x minus 5, and they gave us a bit of overkill. You know, they're all the x's you could use. I'm just going to do a couple. When x is 0, y is negative 5. So that means that point. When x is 1, y is 3 times 1 take away 5. 3 take away 5 is negative 2. So 1 comma negative 2. And I'll do that. And there is my line. Now, sometimes you don't always get to plot the point perfectly. So if you click on line 1, there we go. 0, negative 5, 1, negative 2. Can you imagine that there might be a case where this number is a little bit awkward? Maybe it's 4/3. Right. See if that works. Okay. Negative 4 point, lots of 3s there. Right. I could fix it that way. Which is one of the reasons you try and avoid fractions. It just doesn't like them. By the way, I better get that back to the correct answer. There we go, that's the correct answer. So I should be able to just submit answer. And check, got it right. So you do not show all the working that you used to find the y coordinates, or even which x coordinates are used, to see that all you really need to do as far as WebAssign is concerned is draw the line, right? And use that guy with the 2 arrows. First point, click it on the second and it draws the line and you are good to go. And there's a thing you can watch to help you out. Okay, let's pretend I was doing this one. Now, do you see that they're being really nice and telling you the X's to use? And have you noticed that they're all in the 3 times table? So I'm going to pick 0 because I want to just pick a couple of easy ones. If X is 0, Y is 3. So that ends up being that point. Oops, first you click on it. It ends up being that point. Now, if you pick X as 3, for instance, and you plug it in here and you do the calculation, you get the answer is 1. So X is 3 and Y is 1 is that point. And then you would do, oops, well, you could do watch it if you want, but submit. And that one should be correct. And of course it is. And you could also, if you wanted to, you know, practice another and so on. Now in question 8, they've given you the equation and they've told you X is 1, tell me who Y is. Right, and if I put -1 there, I get -8. So I'm typing in -8. And the ordered pair is -1, -8. An ordered pair is just another name for the coordinates. And you do it for the other two. And let's just see what practice another looks like. There you go. And you can practice with different questions so you feel comfortable. This one is pretty much the same. In this case, they don't tell you who to use. But in this particular case, as long as that number is a whole number, can't you just pick 0, 1, and 2 for X and you'll be fine? Or 0, 2, 4 if you felt like it. Same with that one, pretty straightforward. Right, in this one here, I wouldn't choose X as 0. Well, I might choose X as 0, but I wouldn't choose X as 1 or 2 because 4/3 X doesn't play well with those values of X. Since it says 4/3, I'll pick numbers in the 3 times table. So I would pick X is 0, X is 3, and X is 6. Now, if you put X equals 0 in there, you get 0, 0. If you put X equals 3 in here, you get 3, the answer is 4. And I didn't need a third one, and we're done. Now, I hope when you look at question 12, you will be picking values of X in the 5 times table. How about 0 and 5, or 5 and 10 if you want? Now we've got this fella, right? It's a little bit trickier this time, isn't it? Now, what I would suggest you do is look at the number that's next to the Y. Now, since this number is 1, you can actually get away with X equals 0, X equals 1 and 2, and you will be fine. So for instance, if I did X equals 0, the Y coordinate would end up, when I solve it, being -5. So that would be 0, -5. If I make X equals 1, that becomes 2, that becomes 3, you end up 1, -3. And there you go. And let's just submit it. Looks good, right? Correct. Now you notice that it had 1 Y there, right? Now, just for argument's sake, if this had 2 Y or 3 Y, I would be using, let's say I had 2 Y, I'd probably be using X equals 2 and X equals 0 and 2, things like that, 0, 2, 4. If it was 3 Y, I'd be doing X equals 0, 3, and 6, and hopefully that would work. Doesn't always work because sometimes the numbers just don't play well, in which case you just do a little trial and error. You just need to find 2 guys that come out as nice numbers, 2 coordinates, an X and a Y, and plot them, and you'll be done. In this one here, I would pick 0 and 9, and it works really well. Now, what about a special case, Y equals 1? There isn't any X in that. In fact, what you have to understand to do this one is to realize that y equals 1 is just all the points whose y coordinate is 1. So as long as I pick points whose y coordinate is 1, they will fit on this line. So how about 0, 1? Oops. How about 0, 1 and 5, 1? Now you notice that when you look at all the points whose y coordinate is 1, don't you just end up with a horizontal line passing through the y-axis at 1? And if, let's see if we can skip to it, if you had something like x equals -1, wouldn't you just end up with points whose x coordinate were -1? And it shouldn't be a surprise, say, I hope it's not. They end up with a vertical line when that happens. There's another one of those. In this case, I would be okay. I think you could get away with x equals 0, x equals 1. That would work. In this case, that's an 8. So how about 0, 8, 16? And time for me to show you another way to come up with at least 2 points on the line. Sometimes that's the best you can do. And we're looking now at number 5. And number 5 says graphing a linear equation using the x and the y intercepts. So let's show you what the x and y intercepts would look like. Can you imagine I have a straight line that looks like this? The place where it crosses the x-axis, let's say it's -3, that's called the x-intercept. And the place where it crosses, let's suppose that's 2, the y-axis, that place, that point, is called the y-intercept. Now, if you can find these two guys, you've got the 2 points that you need, draw a line through them, and you've got your guy. So that particular x and y intercept is sometimes helpful when you're doing standard equations. So suppose I did 2x plus 5y equals 20. I wanted to sketch this guy, and I'm going to do it by only finding its x and its y intercepts. Right. To find the x-intercept, which is this guy here. Whenever a line crosses the x-axis, the only thing you know for sure is that the y-coordinate is going to be 0. So to find the x-intercept, make or substitute y equals 0 and solve. Well, let's see what we have. 2x plus 5y equals 20. 2x plus 5 lots of 0, which is still 0. 2x is equal to 20. Divide both sides by 2, and you've got 10. And so we now know where the x-intercept is. It's at 10, 0. So it would be probably about here, right? That's the x-intercept. Now you do a similar type of thing if you want to find the y-intercept. The y-intercept is where the line crosses, right, the y-axis. And the only thing that the y-intercept shares, all of them share, have you noticed that their x-coordinate is going to be 0? So it's kind of switch places there. So what you do is you make the x-coordinate 0, and then you solve. So I am looking at 2x plus 5y equals 20. 2 lots of 0, 2 lots of x is 0, is 0 plus 5y equals 20. 5y equals 20. Divide both sides by 5 and you get y equals 4. And that means that we now have our y-intercept, which is 0, 4. So if I do 0, 4, it's about here. And there is my x-intercept, there is my y-intercept. There's the equation, 2x plus 5y equals 20. So we've graphed the linear function. Okay, let's show you what that looks like then in the homework. So, tells you what to do, find the x and y intercepts and then graph it. Right, if you want to find the x-intercept, make y 0. So that disappears, and what you're left with is negative 16. And its coordinates then are negative 16, 0. Now, the y-intercept, make this guy 0 and solve what's left. Well, negative 8y, take away that, y ends up being 2. So what you've got here is 0, 2. Now, if you go to your grid here, you choose that choice, and you want negative 16, 0, you click on that guy, and you want 0, 2, you click on that guy, and there is the line that they want. And I'm now going to submit answer, and I want to see a straight line with a nice green check mark, which it is. So I know I've done it correctly. Here's another example of the same type of question. And now we're moving on to our final section in linear functions, chapter 3, and that is applications. So what we have here is a story that's going to generate, hopefully, an equation. Let's see how it works. A tennis pro is paid $24 an hour for private lessons by members of a condominium group, okay, someplace in Florida, whatever. The equation that describes the total earnings that the pro makes is earnings is 24t, where t is the total number of hours worked. So if he works 10 hours, he will make 24 times 10, right? If he works 40 hours, it's a busy week, 24 times 40 is how much he would earn. Now it says use the coordinate axes to graph this equation. So we are really looking at 4 possible graphs of what this would look like. Now, first thing that strikes me is if t is 0, won't the earnings be 0? So for that reason, I'm throwing that one out, because if you look carefully, you see that's not 0, right? It's above 0. Now, I would probably pick a number that's easy to locate. So I would choose, because I want to, 10. So let's see what happens if he works 10 hours. He will earn 24 times 10, which is 240. So I'm going to look, is 10, 240, 10, 240, 10, 240, and 10, 240. Let's throw each one out. 10, 240. That's definitely not 240, right? It's less than 200. Is that one got 10, 240 passing through it? Nah, it's got more likely 300 words. So that's no good. That one we already kicked out. So the only one that's left by a process of trial and error was that guy. Now it says here the point 20,480 is on the graph. Complete this sentence to describe the meaning of the order pair. The tennis pro will make $480 for working for 20 hours. So do you see that this is how much he earns, and that's how many hours he works, and that's what they want. So I didn't mean to hit watch it, but there's a nice video to show you same thing. Let's submit the answer. And check, check. Right, that one's right. green check mark. This is correct. And there's your last version. And this story is a little bit different. The equation is 0.1n plus 10, but one of these four, and only one of these four, is going to work. And then you've got a little guy here, which is very similar to how I answered this one here. So hopefully everything you want, I've covered. And that's us. Bye-bye.